you in particular, Bob, for giving me the opportunity to speak here. I'm Gerald Cleaver. I'm the Graduate Program Director in the Department of Physics at Baylor University. I also lead the Early Universe Cosmology and Strings Research Group in our Center for Astrophysics, Space Physics, and Engineering Research, aka CASPER, at Baylor. My focus is, as I was saying, is string theory in the early universe. And I've been studying an area that I think can lead to a nice expanded picture of the scale at which Nyota might be working, i.e. the scale at which God works through creation, both through the combined ways of transcendence and immanence. And I'm going to go through the first parts of my presentation on where we are in cosmology. We've taken some huge steps in the last couple of decades of our understanding of the realm of creation, how big it is, how old it is, and the implications of some of the discoveries, in particular what's known as inflation, the inflationary stage of the Big Bang, is one of the most supporting evidence that the creation, the physical realm of God, that God created, is much larger than we have ever imagined. And it's likely much older too. We live in what we call the Hubble volume, named after Edwin Hubble, and that's the amount of our universe that we can see. We're able to go back now. The universe we know is about 13.8 billion years old. And since light travels at the speed of light, we can see things that some of the earliest galaxies, sub-galaxies, we can see the cosmic microwave background as it was almost the full 14 billion years ago. And that's what we define as all the visible universe, the Hubble volume. Right now, the Hubble volume, since we saw it when it was basically 14 billion years ago, it's expanding at almost the speed of light, and for a while, and faster. The total, effectively, volume of our universe right now is about 40 billion light years. That's 14 times 2 plus an extra factor since it's been expanding faster than the speed of light for a while. But we think now that science implies that there is much, much more than just that. And there are levels, and I'm going to discuss possible levels 1, 2, 3, and 4. And these enlarged pictures, we no longer talk about just this as a universe, but we're going to get to extensions of ours that are independent enough that we now refer to them as other universes. Sometimes the terms are parallel universe, bubbleverse, things like that. And they all are part of what we believe is the much larger realm of the physical creation called the multiverse. And I'm going to go over basically how our perception of the physical world, physical existence, has grown through a series of paradigms. And these are, we can call them phenomenological paradigms. They deal with human understanding of creation. And I'm going to go through those first, and then deal with some of the issues of how God likely interacts with creation, and in particular with the sentient beings within that creation, as we consider some of the forms of the multiverse. And again, we're at the point of theorizing what is beyond the observable universe. We can only theorize because, by definition, we can only see within our observable universe. So there's a lot of theorizing right now, and based on scientific starting point, but admittedly, scientists, cosmologists working in these areas acknowledge that we are necessarily forced to deal with it from philosophical aspects. Whenever we're dealing with origins, in science, you're always having to include philosophical aspects and acknowledge that. This bothers some scientists. They just basically don't want to go there because we pass the grounds from science into philosophy and theology. But we have to. It's necessary. You can't avoid the boundaries without acknowledging that. So I'm going to start back again, just a brief overview of the paradigms of creation, as I'll call them, that we went through. We can start, and we can go back to, in the biblical times, what was basically the understanding of reality of the physical world as was in the ancient Mideast world, the prehistory world, to about 300 BC, to the time of the rise of the Greeks, and even in the Judea up through the 1st century. And that was this idea of the 3-tier universe: earth, the land, the firmament of the heavens, including the ocean of the heavens is talked about in Genesis that broke and the flood and all that, and then the underworld floating on the primeval ocean. When we think about this picture, we get a pretty good understanding of the view of the writers of Genesis and all. But then, by the time of Greece, a mathematician by the name of Eratosthenes was one of the leaders that was saying that the Earth was, in fact, a sphere. And he actually computed the radius of the Earth to within 3% accuracy. If you don't always know, Columbus looked at his works, and Columbus thought that he was crazy, that he had drastically overestimated the size of the Earth. But if he had taken the word of Eratosthenes, he would have known that he had not landed on India, that he had stopped far short. But again, Eratosthenes was accurate within 3%, and he computed both the radius and the circumference of the Earth by measuring the local curvature of the Earth. And he could measure what the internal degree was for the curvature that he measured. And so the Greeks well understood we lived on a spherical world, but they pictured that as the center of creation again. The planets and the sun went around it. And phenomenologically, this was very descriptive of reality. But gradually, with the further development of modern science, by the 1600s, we were existing within the heliocentric paradigm of creation. But still, the reality of the universe we were in was pretty much our solar system. The stars were out there, but they were just more theoretical, out in the far distance. So we had the heliocentric paradigm through the 1600s and 1700s. But then with the discovery of an adaptation and development of telescopes and all that, by the 1800s through the 1920s, what I'll call the galactocentric picture came into play. And that was full understanding of the Milky Way galaxy. But even Einstein himself felt up through the 1920s that that's all there was, one galaxy and nothing more. There were, even at that time, there were these small cloudy-like things called nebula. A few Frenchmen and Englishmen classified these, and they had found several hundred of them, but they were, again, just thought to be hot gas inside our galaxy. Until then, developing the 1800s, and then some verification of the distance between these gaseous nebulae, it was realized that they were, in fact, their own galaxies. And this is some recent photographs from the Hubble telescope. And each of these, again, are distant, vastly distant. Again, about as far as we can see away from any of them is almost 14 billion light years. But right now we know that the reality of the observable universe includes a universe of over 1 trillion galaxies. And each one can have up to 1 trillion stars. And now we know that the likelihood of planets existing around those is very good. There's patterns within the observable universe too. And this is it. This is basically a map of reality as we know it now. It's not cubical, but I'm just putting that up in here to get some sense of depth of it. But that is what I would call the universe-centric picture. And that's been in place since the 1920s. But we're at a point from understanding the properties of the observable region of the universe that there has to be something more outside the bounds that we can't see. And this is where theoretical cosmology is really at, trying to understand what is beyond. What I'm doing, besides as a scientist, is my theological interest is also understanding how do we interpret the vastness of creation, in particular, what more there is beyond just the observable region. And how can that be applied to things like an iota and the idea of God working inherently within creation, both in immanence and simultaneously transcendence. And what I get as I'm thinking about this, and in particular the expanded picture that we are in, I see a duality between those two that I think works out well within the proposal that Bob has. I'm running out of time a bit, but we know several things about the visible universe. The history of this universe is well understood, down to both from the present time back to just a fraction of a second after the Big Bang of space itself. It's not just theoretically understood too, but there are experimental predictions that have been verified. Things like the ratio of hydrogen to helium in deep space, away from other stars that could have affected things. The ratios are predicted, and those ratios, in fact, not just helium to hydrogen, but lithium to hydrogen, deuterium to hydrogen, all those that are very critical on the conditions of the early universe within the first second to about 21 minutes. Those all match very well between the theory and the experiment. We couldn't have a good understanding of the universe down to fractions of a second without these theoretical predictions being consistent with the experiment, and they are. And so we really know the short history of the universe, in particular, this origin of the universe at time zero. We basically know it down to less than 10 to the minus 33 seconds. And this inflationary stage that had to have happened then. And inflation is a stage where the universe itself expanded much faster than the speed of light. And it grew from much smaller than the size of a nucleus of an atom itself to roughly the size of a soccer ball within a second. It expanded by a factor of e to the 60, which is about 10 to the 30 or so, greatly faster than the speed of light. The physics that could cause that is not known specifically, but it is fairly well known. It's more in terms of the specific physics that could produce that effect, or the range of physics. And this physics is also supported, and the implications of it in the effects, by the measurements of the cosmic microwave background. And the measurements of this have been, over the last 30 years, have improved greatly. So we know the variations of the original energy densities in the universe based upon how much the temperature varies of the cosmic microwave background that we see. This was light that was emitted when the universe was 380,000 years old. The universe was just cool enough then for electrons to be captured by the nucleus of atoms and the light freed. And the light that was freed then showed the density of the universe even much, much earlier. And we have an issue in the cosmic microwave background that shows that the universe, what is observable now, was very, very constant in temperature, up to 1 part in 10 to the minus 5. And that's not predicted, because inherently, without inflation, we should see much, much stronger variations in temperature. And so this implies that the universe had to have expanded faster than the speed of light very, very early on for the symmetry of the temperature. Just had the variations shown by colors there of only 1 part in 10 to the minus 5. So there's strong evidence for inflation. And then inflation itself implies that there had to be some type of physics that would produce it. And this is where either we continue with science into this realm, or we simply say that God did it. But as a Christian in the sciences, I want to try to understand the physical description of that process. And this is where, when we get into that process, the implications are basically that we're not going to, that if the physics is right and we really are understanding it, the physics that could produce a universe like ours going through this inflation stage, it's a physics that is very, very unlikely to just produce one universe at a time. That if you either get inflation producing a vast number of universes, or we just totally understand the physics really wrong. The analogy that we use to try to understand what we're talking about now is boiling a pot of water. You've just reached the boiling temperature. And who is going to expect just one bubble to form and nothing more? That could happen, but it would be very, very improbable that the temperature distribution in the water is going to range itself for just one bubble. And the analogy of just producing our universe alone is a lot like that. It's very improbable, and we refer to producing universes out of the underlying space-time much like that. We refer to them as being nucleated, just like in a bubble, a boiling effect. And so what we're really getting to is going back to this point in the history of the universe, where we see the universe is growing and growing. It has been 14 billion years. For the Big Bang to have occurred right here, you had to go through inflation to produce the physics that we know now. And that inflation likely had to lead to many, many more universes. And that's saying that if science can describe the conditions of the universe down to time zero, then it is telling us that the God, transcending and immanent in all of this, did not just create our universe then, but through the scientific description, and this is where we're working, and God, both transcendent and immanent in the process, produced likely a vast number of differing universes. And in my studies, what I do is to try to understand the physics and the conditions of these other universes. How much would they vary? And there's been a lot of work in that, in, again, what's in my area known as string theory. We've worked to determine, under some certain assumptions, known as the string M theory process, what the universes would have been like. How much would the physics have varied? How probable is it in any of these specific universes that life would have evolved? And not just life as we know it, but even other drastically different types of life. You know, is other conditions possible? And we really are looking at something where we have, again, think of the analogy, because the science and physics it's beyond our understanding to really picture it without using analogy, because we really have to in science. Think of these bubbles, these universes as forming, bubbling out, like in a pot of water. And so they're higher dimensional. We think of these as bubbles forming or expanding out like this. Each one is an independent universe, and the laws of physics are self-contained. The laws of physics in this universe likely is drastically different in this one, and that one, and that one. We've worked out the numbers of how many different types of physical universes there can be based on the assumption of that I said I'm working in the area of the assumption of string M theory. The number is, it sounds like just something I'm throwing out of the air, but I can give you several papers, a whole series where they've been computed. The number of universes with differing physical laws is 10 to the 500. And one of the things, if this theory is correct, what I'm doing in my research group and my PhD students in particular, and there's about 16 other universities in the U.S. Working as a group and coordinating and sharing the data, and there's an equivalent one in Europe. We're studying regions computationally of this set of 10 to the 500 to get some idea of what the probability is that we can find a universe theoretically matching our conditions of ours in here. Because if the string M theory multiverse is true, then a universe in this set of theoretical ones has to have conditions that match ours. So if it's not, then it doesn't work. So we're doing that, and the whole thing has come out that we have this vast understanding, 10 to the 500 or so. And we have this picture of different types of universes, different futures. We have this whole set. They've been classified by levels, and I don't have time to go through the levels, but you can look on the web under the scientists who drive the classification of the different types of collections of universes is a cosmologist at MIT by the name of Max Tegmark, Tegmark. And he's developed a level process that I don't have time to get to. But the most interesting are levels 1 and 2. Level 2 is this collection, which in string theory would be this collection of 10 to the 500. And the idea that likely at any given time, some proper subset of this exists. And they exist in the sense of they are there outside our universe. And what I've been doing, again, is now trying to think in terms of some of the theological implications of this. And I've tried to apply some things, and again, I don't have time to get to it, but I'm just going to reference a little bit. For me, I've thought about how does the concept of the multiverse apply with our understanding of God? And I've tried to extend some things like Anselm's ontological argument. I've applied it not in the sense of it argues existence of God is better than non-existence, but I'm thinking in terms of the creation of God, the scale of it. And I think, and I'm reaching some interesting conclusions. I've talked about it in my paper for the conference, but again, I don't have time to go into all of that. But I'm going to stop right here. I'm out of time. Just where we are, we've talked about, I'll talk about the quantum mechanical level, small scale. I'm talking about the hugeness of creation. And the interesting thing is we've also found that even in this vastness of the multiverse, quantum mechanics ends up being the underlying overriding law. So all of this would apply to all of the iota. That's what it is in action. We found out even gravity ends up ultimately being an effect of quantum mechanics. So I'm going to stop there. I think this just presents the picture I'm working at. I don't really have time to say more. Two questions? I went go on and on. Ted.
Let me ask about your assumption. Does necessity play a role? If we take a look at the boiling pot on the stove analogy, you get some bubbles and they're random. Mm-hmm. When it comes to the, what was it, 10 to the 500th, mm-hmm. Possible universes, is it necessary that every one of those possible universes be actualized, or might it just be some of them, and those that get actualized are just a random number without any necessary principle at work?
Yes, I would say the latter. It's not necessary. It is probabilistic that you would choose out of those. And to have one that would have, for example, if the number is 10 to the 500, we've determined that what we would need to produce the value of the cosmological constant, it would be in a probability of 1 out of 10 to the 120. So if the actual number is 10 to the 500, then subtract 500 minus 120. That would say that there is roughly 10 to the 380 universes that have our conditions for the cosmological constant. Then there are other conditions for the forces in nature that we know. How many would be within that set of 10 to the 380? So it's probabilistic. And when I say 10 to the 500, rough number, because we don't know. It's a range, 10 to the 100 to 10 to the 1,000. We talk about the average. One more question, and then I'm out of time. And you, I think it was you. Go back.
You can give us to your publications on theological implications?
Yes, I have some, and the one here, yes, I can.
Okay.
Thanks, Jerry.
Thanks.